Hey, what's going on, guys? I hope you're all doing well today. This time, I'm going to make a video showing the practice of reverting the PS4 firmware or rolling back the firmware version to the one before the last update. Why do I say practice? Because this is my first time doing it after learning how from various YouTube channels. So now it's time to put it into practice. Also, I'm not a technician or someone who regularly does things like this, so there's a chance it could fail. But regardless of the outcome, whether it succeeds or fails, I'm still going to upload this video. Proof being, you're watching it right now. So the question is, did I succeed? To find out, make sure to watch this video until the end. Okay, before we start, let me briefly explain what reverting firmware means. As I mentioned earlier, reverting firmware, in simple terms, is restoring the firmware version to the one before the last update. For example, if your current PS4 firmware version is 11.00 and you updated it to the latest version at the time this video was made, which is 11.50, with a firmware revert, you can roll back to version 11.00, even if there was an intermediate version, like 11.02. However, if you updated twice, for example from version 11.00 to 11.02, and then to the latest version 11.50, you can no longer go back to version 11.00. You can only revert to version 11.02 because that was the last version before your most recent update. That's why reverting firmware is not the same as downgrading, because you can't go back to just any firmware version you want. Hopefully, this simple explanation makes sense. Alright, now let's move on to the firmware revert process. First, let's prepare the necessary tools: a soldering iron, solder tin, flux, alcohol or PCB cleaner, jumper wires, and Kapton tape. During the firmware revert process, there is a step to back up and restore the binary files from the NOR and Syscon chips. To do this, we need a microcontroller called Teensy, specifically the Teensy++ 2.0. We also need some electronic components that function as voltage regulators and step-down converters. The first one is here. You can read the component code yourself. Then, there's another one, which is very small. Here's the code for that component. Next, we also need resistors with values between 100 and 200 ohms. This next part is optional but not mandatory. The CP2010-2 USB 2.0 to TTL. This is used to view the log process when the PS4 is booting. It's very useful for identifying error messages if your PS4 doesn't turn on after the revert process, so you can troubleshoot based on the error message. Finally, a mini switch is needed if you want to install the Teensy permanently in your PS4. Those are all the requirements and equipment needed to perform a firmware revert. Before we can use the Teensy to dump and restore the NOR and Syscon chips, we need to solder the two components, the voltage regulator and resistor, to the Teensy. I actually recorded the soldering process, but for some reason, when I checked the SD card, the file wasn't there. So here, I can only show you the result after it's soldered. The larger component is installed like this. And for the very small one, it's installed like this. Make sure to pay attention to the pin positions. Don't mix them up. Then, cut the trace in this section. You can use a needle or cutter. And then bridge the 2 points above it with solder. The result will look like this. Here's how it looks after we install the voltage regulator components and bridge the two traces I mentioned earlier. Next, we'll install a 100 ohm resistor to pins D2 and D3. And this is how it looks after being installed. To ensure that the Teensy assembly is correct, we need to measure the voltage from the VCC connection on the smallest voltage regulator component. First, plug the Teensy into the computer, place the black probe on the ground, and the other on the end of this component pin. The voltage should read 2-point-something volts, like this. Next, we'll solder wires to several pins on the teensy, which we will later connect to the PS4 motherboard. Start with the ground pin, then D2, D4, and D5. On the other side, solder to B6, B4, B3, B2, B1, and B0. Finally, solder the last wire to the end of the smallest voltage regulator component to connect the VCC to the PS4. Alright, let's get started, beginning with the ground pin. Please bear with me if you see my hands moving a lot. As I mentioned earlier, I'm not a technician, so I'm not very skilled, including with soldering. Let's move on to the other side, starting with pin B6 and so on. Lastly, we'll solder the VCC pin to the end of the teensy. Alright, done. And here's the final result. I fed the VCC wire through a hole like this to prevent the solder from coming loose if it gets pulled. The tool for backing up and restoring NOR and Syscon chip data is now complete. Let's move on to the next step, which is soldering these wires from the teensy to the PS4 motherboard. Before I disassemble the PS4, let's update the PS4 firmware to the latest version since my PS4 is still on version 11.00. So let's switch over to the PS4. Before updating, I'll show you the current firmware version. Here, you can see it's version 11.00. You can also take note of the MAC address as proof that we're using the same PS4 when we revert it later. Alright, let's go ahead and update. First, we'll connect to the internet. Go to System, Software Update, and here it detects firmware version 11.52. Let's go ahead and hit Next and wait for the update process to finish. Okay, the firmware update process is complete. Let's check the firmware version again. As you can see, it's now version 11.52. Now, let's try logging into PSN. I've already logged in, and you can see the games available for purchase. And this is the only game I've ever bought. So the question now is, can I revert this PS4 back to version 11.00? Make sure to watch the video till the end because, whether I succeed or fail, I'll upload the video as a learning experience for all of us. Alright, let's disassemble the PS4. I won't show the full disassembly process here. You can watch how to disassemble the PS4 on other YouTube channels. We don't need to take everything apart, just the bottom section. But we do need to remove the screws from the top part, as these screws hold the metal frame of the bottom section. Okay, the metal frame is off, and now we'll solder the wires from the teensy to the PS4 motherboard. Before we proceed, I should mention that the solder points for the wires from the teensy are different depending on the motherboard model, except for the connection to the Syscon chip, which is the same for all models. My PS4 motherboard model is SAD002, and the connection points are as follows. For the ground connection, you don't need to solder to the Syscon chip pin. Instead, you can solder directly to the brass plate on the motherboard. If you have a different motherboard model, you can check Modded Warfare's YouTube channel, where he shows the exact connection points for the teensy to the motherboard for all PS4 motherboard models. Alright, after identifying the solder points, it's time to solder the wires from the teensy to the motherboard. First, We strip the plastic coating until the brass layer is visible so the solder can stick. I'm using the tip of a large needle for this. Once exposed, we apply flux and solder until the solder sticks to each connection point. Then, we solder the wires from the teensy to the corresponding points as shown in the previous diagram. Lastly, we clean the area with alcohol. The connections to the NOR chip are done. Now we move on to the Syscon chip. Before soldering, we need to detach the 15th pin of the Syscon chip from the motherboard. This pin will be connected to pin D4 on the teensy. This step is necessary to dump data from the Syscon and also to activate debug mode. It only needs to be done once, after which you can solder the Syscon pin back to the PS4 motherboard. This is the most challenging part because there's a risk of breaking the Syscon chip pin. There are various techniques for lifting the Syscon chip pin. Here, I used a small wire, hooking it onto the 15th Syscon chip pin and gently pulling while heating it with the soldering iron at the same time. However, I accidentally pulled the wire too hard and the Syscon pin came off without even needing to be heated first. Fortunately, the pin didn't break. Since the pin is now detached, we can go ahead and solder it to the wire connected to D4 on the teensy. Then, we solder the wires to D2 and D5 as well. Lastly, we clean the area with alcohol. Alright, all the wires from the teensy are now connected to the PS4 motherboard. Here's how it looks on my PS4. As you can see, I've added a mini switch to each wire between the teensy and the PS4 motherboard. I'll explain later why I installed these switches. I've also soldered the wire for the CP210 USB to TTL. Now let's move on to the next step. In this step, we'll dump or back up the data from both the NOR and Syscon chips. Then we'll patch or modify this data. After that, we'll restore the modified data back to the NOR and Syscon chips. To do this, we need to download and install a few applications. First, we need the latest version of Python. Then, download PS4 HEN tools by Andaman, PS4 Syscon tools by Upcararino, Norway by Hedgiges, and Putty if you're using CP210 USB to TTL. After downloading Norway, open the spyway README file in the folder. Then, download two additional files, Python version 2.7 and PySerial, using the respective links. I've already downloaded all the necessary files, so now we'll install them in order, starting with the latest version of Python, followed by Python version 2.7, and finally, PySerial. Okay, let's install the latest Python version. Before clicking Install Now, don't forget to check the two boxes below. We'll wait for the installation to finish. Then, we'll move on to installing Python version 2.7. Lastly, we'll install PySerial. Don't forget to select version 2.7 here, and then click Next until the installation is complete. To ensure that Python has been installed correctly, open the command prompt and type the following commands. If both Python versions appear as shown, then we've successfully installed Python. After that, we can delete the 3 installer files since they are no longer needed. Now we'll proceed to back up or dump the files from both the NOR and Syscon chips, starting with the Syscon chip. First, we need to program the teensy so it can connect to the Syscon chip. Plug the teensy into your computer, Then open the PS4 Syscon Tools folder, navigate to HW, then to Loader. Run the teensy application from there. Next, go back to the HW folder and open the teensy++ 2.00 folder. Drag the hacks file onto the teensy application, then click the Auto button. After that, press the Program Mode button on the teensy board until you see the message Reboot OK. Now, the teensy is ready to back up the Syscon chip. To do that, open the PS4 Syscon Tools application located in the PC folder. Make sure Dump Full Syscon Flash is selected. Then, select the location to save the backup by clicking the three dots. I've created two folders here. One for the Syscon chip and one for the NOR chip. Now go back to the PS4 Syscon Tools application and choose the folder for the Syscon. Type a name for the backup file. I'll name it Syscon, then click Save. Make sure the number here is set to 2, meaning we'll back up the file twice. Finally, click Start to begin the Syscon chip backup process. Wait for the first backup to complete, then it will automatically proceed to the second backup. Once the second backup is finished, make sure the message "Files are identical" appears. Next, we'll back up the NOR chip. Similar to before, we first need to program the teensy so it can connect to the NOR chip. To do this, go to the PS4 Syscon Tools folder and once again run the teensy application from the Loader folder. This time, the file we'll use is the spyway.hacks file located in the Norway, Spyway, and Release folders. Just like before, drag the file onto the teensy application, click Auto, and then press the Program Mode button on the teensy board. Once the teensy is successfully programmed, go back to the root folder of Norway Master. Now, we'll open the command prompt with the path set to this folder. To do this, click the bar at the top of the folder window and type cmd. Before backing up the NOR chip, let's first ensure that the teensy can connect to the NOR chip by checking the chip information. Type the following command. Make sure to adjust the COM5 to match your computer's port, as it could be different from mine. To check this, right-click the Start menu, choose Device Manager, and click the arrow next to Ports, COM, and LPT. Find the USB serial device and see which COM port it is assigned to. In my case, it's COM5. After typing the command, press Enter. If chip information like this appears, it means the teensy is ready to back up the NOR chip. Now, we'll back up the NOR chip with the following command. To avoid retyping everything, press the up arrow key to bring up the previous command, then erase the info part and type dump, followed by the file path where we'll save the backup. To do this, go to the folder you've prepared. Click the address bar at the top and copy the path. Then return to the command prompt, right-click to paste the path, and add a file name like s/01.bin. I'm adding 01 because we'll back up the NOR chip twice, just like we did with the Syscon chip. Ensure that the full file path and name are inside quotes. Press Enter to begin the first backup process. Wait for the first backup to finish. Once done, we'll proceed with the second backup. Press the up arrow key again to bring up the previous command and change the 01 to 02. Press Enter to start the second backup. Once the second backup is complete, we can check the backup results for both the Syscon and NOR chips in the folder we prepared earlier. As you can see here, each chip has 2 backup files. Okay, before modifying, we'll copy all the original backup files to save them as a backup in case you need them later. If either your Syscon or NOR chip gets damaged and needs replacement, you'll need these backup files. Next, we'll modify or patch the backup files for the Syscon and NOR chip. First, go to the PS4 WeTools folder and copy the PS4 WeTools application to the revert files folder where we stored the backup files. Then, run the application. Next, we'll choose the File Browser menu by pressing 1. Then, select the NOR folder by pressing 1. Now, let's check if both NOR backup files are identical by pressing C. As you can see here, the status shows they are identical. Next, we'll go back by pressing Enter, enter the NOR folder again by pressing 1, and select one of the NOR backup files by pressing 1. Here, we can see detailed information about the NOR chip backup file. The most important details are these two. You can see the firmware version installed on the PS4, which is version 11.52, and the backup firmware version, which shows the firmware version we can revert to. From what we see here, we can revert to either version 10.50 or 11.00, but it seems like we can only revert to version 11.00, as we previously confirmed that the firmware version before the update was 11.00. Next, make sure the UART status is set to On. If not, you can press 1 to change it to On. For the patching process, we'll select menu number 4. Here, you'll see a list of slot switches that we can try one by one. You should choose the appropriate one for your PS4 model. Since my PS4 is a Slim, I'll select numbers 3 and 4. If the slot switch we choose doesn't succeed in reverting the firmware, we'll try again with the remaining slot switches below. For the first attempt, we'll only use slot switches 3 and 4. Okay, let's start by pressing number 3. Press Y, then press the asterisk to cancel because we won't directly flash to the NOR chip yet. Let's also create slot switch number 4 by pressing 4. Press Y, then press the asterisk. Now, we have 2 NOR chip files, each patched with slot switches 3 and 4. Later, we'll restore these files to the NOR chip one by one. If slot switch 3 fails to revert the firmware, we'll restore the file patched with slot switch 4. If that fails as well, we'll create slot switches starting from 5 and continue restoring them to the NOR chip one by one until it works. I hope you understand the process of patching and restoring the NOR chip. Next, we'll patch the Syscon chip backup. Press 0 to go back, press M to return to the main menu, press 1 to select the file browser again. This time selecting the Syscon folder, press 2. Then select one of the backup files, press 1. Now, you'll see the Syscon chip backup file information, and it says that this PS4 can possibly be patched. Next, let's change the debug status to On by pressing 1. Now, the status has changed to On. For the next step in the patching process, we'll select menu number 3. Here, choose the option recommended for your situation. I'll choose Method B, as it's recommended here, so I'll press 2. Okay, we have now successfully patched the Syscon chip backup file. With this, the patching process for both the NOR and Syscon chip backup files is complete. The next step is to restore the patched or modified backup files to both the NOR and Syscon chips. It's important to note that we restore the NOR chip first, followed by the Syscon chip. Alright, now let's restore the NOR chip. Just like before, we'll first program the Teensy to connect to the NOR chip. Open the Teensy Loader application again, then drag the spyway.hex file from the release folder into it. Click Auto, and press the Program Mode button on the Teensy board. Open Command Prompt in this folder, just like before by clicking at the top here and typing CMD. We'll ensure the Teensy is connected to the NOR chip by using the following command. Make sure to adjust COM5 according to your computer's settings. As you can see, the chip info appears here. Before we restore, we need to erase the chip data using this command. Now, let's wait for the chip data to be erased. Okay, the chip data erasure process is complete. Now, let's proceed to restore the modified backup file using the following command. After typing VW-write, add the path to the file. Here's how. Navigate to the file location. We will first try the file from slot switch 3. While holding down the Shift key, right-click on the file name and select Copy as Path. Then, paste it into the command prompt. Once done, hit Enter to start the restore process. This will take around 10 to 11 minutes. Oops, an error occurred during the restore process, likely because I was using a USB extender cable. Let me plug the TNZ directly into the computer. Now, let's repeat the previous command. Okay, the NOR chip restore process is complete. Next, let's restore the Syscon chip. Just like before, we need to reprogram the TNC to connect to the Syscon chip. Then, run the PS4 Syscon tools. First, click on the Options menu and enable Advanced Options. In the Syscon Process menu, select Write Syscon NVSS NVS only. Below that, choose the modified Syscon backup file by clicking the three-dot button. Locate the modified Syscon backup file. Click Open. Make sure the Verify After Write option is checked. Lastly, click Start to begin the Syscon chip restore process. Wait until the Syscon chip restore process finishes and ensure you see a successfully message like this. Alright, all steps are complete. Finally, we just need to turn on the PS4. Before doing so, we must remove all the cables soldered to the motherboard from the TNZ. Additionally, the 15th pin of the Syscon that we lifted earlier needs to be carefully soldered back to the motherboard. Be cautious here to avoid breaking the pin. This is necessary because the PS4 won't power on if this step isn't done. The issue now is that there's a possibility the files we restored to the NOR and Syscon chips earlier failed to revert the PS4 firmware. This means we need to try restoring again with a different modified NOR chip file. As for the Syscon chip, even if the modified file remains unchanged, we still have to restore it again every time we restore the NOR chip. To do the re-restores, we would have to resolder the TNC cables back to the PS4 motherboard, except for the D4 cable from the TNC, which was previously connected to pin 15 of the Syscon chip. That connection doesn't need to be re-established, as it was only done once to enable debug mode. This process can become quite cumbersome, especially if multiple file restores are necessary. That's where the function of the switches I've connected to each cable comes in handy. Instead of unsoldering the cables from the PS4 motherboard, I can simply disconnect the cable connections via the switches. If I need to restore again, I just toggle the switches to the on position. I followed the tutorial from Modded Warfare where only 3 cables had switches, but even after trying that, the PS4 still wouldn't power on. Now, the switches are turned off, so let's power on the PS4. I will also connect the PS4 to a TV to see the result, but since I'm using a CP2102 USB 2.0 to TTL, I don't actually need to connect it to the TV. Instead, I'll monitor the PS4 boot process logs through the PuTTY application. For the setup, first, connect the CP2010-2 USB 2.0 to TTL to the computer. Then open the PuTTY application. In the Connection Type section, select Serial. For Serial Line, enter the COM port used by your computer. You can check this the same way we did for the TNC by going to Device Manager and checking under Ports, COM and LPT. In my case, it's COM7. Set the speed to 115200, then click Open. Finally, just power on the PS4. There are two possible outcomes here. First, the PS4 could boot normally with the same firmware version, meaning the firmware revert process has failed, and we will need to restore the modified NOR chip file again with a different slot switch, and, at the same time, restore the Syscon chip as well, even with the same modified file. As I mentioned earlier, every time we restore the NOR chip, we also have to restore the Syscon chip. The second possibility is that the PS4 boots into safe mode, asking us to connect the controller via cable and then prompting us to reinstall the firmware. This would indicate that the firmware revert process has succeeded. Now let's check the result. I'll press the PS4 power button, and we'll look at the PS4 boot process log on the computer through the PuTTY application. Okay, the log shows that the boot process has started, indicating that the PS4 is booting. What we need to pay attention to here is the topmost line. Here we can see that the secure loader build shows the number 11.520, which corresponds to the firmware version. This means the PS4 has booted with firmware version 11.52. Therefore, it indicates that the firmware revert process using the modified NOR chip file with slot switch 3 has failed, since the PS4 is still booting with the same, unchanged firmware version. For that, we need to restore the NOR chip again using a different slot switch, along with the same Syscon chip. I won't show the next restore steps here since the process is the same. After 7 failed attempts, let's check the 8th attempt. Let's view the PS booting log. As you can see, the secure loader now shows version 11.00, which means we have successfully reverted the firmware back to version 11.00. If we connect the PS4 to the TV, we can see that the PS4 is in safe mode. Now, we just need to install firmware version 11.00. To do that, we first need to download the firmware. Here, I've already opened the website that provides firmware archives. Make sure to download the recovery firmware, not the retail one. Let's search for version 11.00 firmware and click here to download it. Once the update file is downloaded, copy it to a flash drive formatted to exFAT or FAT32. Inside the flash drive, create a folder named PS4, and within that folder, create another one named Update. Place the update file there. Once done, plug the flash drive into the PS4. Select OK to start the firmware installation process and wait for it to finish until the PS4 restarts. The PS4 has now restarted. Let's check if the PS4 firmware has successfully reverted to version 11.00. As you can see here, my PS4 firmware has successfully reverted to version 11.00 after previously being updated to version 11.52. The firmware revert process was successful after using the modified backup NOR chip file from slot switch 8. After the successful firmware revert, there is one more important thing to do. You must immediately secure the backup NOR chip and Syscon chip files that successfully reverted the firmware. In my case, the NOR chip is from slot switch 8, and the Syscon chip is from patch file B. This is important because, even if I update the firmware multiple times, I can still revert back to version 11.00 since I have the backup NOR and Syscon chip files that allow me to revert to that version. So, it no longer matters if you can only revert to the last updated version. As long as you have these two backup files, even if you update your PS4 thousands of times, you will still be able to revert to version 11.00 or any firmware version corresponding to the backup files you have. Secondly, with these backup revert files, you can freely switch your PS4 between PS4 HEN homebrew enabled and the original firmware. So when you get tired of playing offline games and want to play online games like PUBG, Fortnite, Apex Legends, Genshin Impact, or other online games, you can simply update your PS4 firmware to the latest version, log into PSN, and download the games. Conversely, if you get bored of online play, whether it's because you're losing a lot or you're just not great at Battle Royale games, and you want to go back to playing on PS4 HEN, you can easily revert the PS4 firmware using these backup revert files. This is why it's so important to keep your backup revert files safe. Alright, that was the result of my attempt to revert the PS4 firmware, and it turned out to be successful. You can follow this video as a tutorial, but proceed at your own risk. All the materials for the firmware revert are linked in the description. I'll end this video here. If this video was helpful, don't forget to like and subscribe. If you have any questions, feel free to write them in the comment section. Thank you for stopping by the channel, and see you again in the next video.